Hello everyone. In this video we're going to cover Chapter 4, Describing Variability. Here's an outline of the topics we're going to cover in this video. First, we're going to cover the learning goals, the knowledge and skills I want you to have as a result of watching this lecture. Second, I'm going to tell you about some of the practical applications, some of the things we can do with this idea of variance and variability in the everyday world. Third, of course, we're going to cover our module content. Fourthly, we'll cover some example problems to get you comfortable using these different formulas. And lastly, we'll do a quick review and recap. These are the two learning goals we're going to cover today. And in essence, they boil down to three different formulas. So I want you to be able to calculate the range, variance, and standard deviation for a set of data because these are three different indices of dispersion. So before we get started, I just wanted to give you an idea of what variability looks like. In the last video, we covered mean, median, and mode, these different indices of central tendency. Here we're going to talk about the width of distributions. So how are scores distributed across the range of values that exist? Here we have two different frequency distributions. On the x-axis, we have raw scores. In this example, we have 1 to 7. That's what these scores range on, whatever hypothetical variable we have. And on the y-axis, the vertical axis, we have 0 to 9, and these are frequencies. So in this example, 8 individuals have a score of 4, right? So 8 people fall under this 4 category. 6 people have a score of 3. That's what this bar indicates. And 2 people have a score of 2. That's how a frequency distribution is generally laid out. And as we can see, even though these two distributions both have an average of 4, their variance or their variability is very different. So the chart on the right has a wide distribution and there's high variability. The chart on the left has a tall and narrow distribution, so it has low variability. So why and when is it important to understand variability and to be able to describe a distribution or a data set's variance? Well, there are lots of examples, but I'm just going to give you two. So, for example, in the context of experiments and treatments, we might be interested in the effectiveness of a new drug or a new exercise program. And let's say if we are doing a new drug, the prescription is for participants in the treatment group to take it 3 times per day. So ideally, everyone would take it 3 times a day, so we would have a clear idea of how effective this drug is. But what if some people only took it twice, or some people only took it once? Are they truly the same as the other individuals who took it 3 times in this treatment group? Well, the answer is no, and that creates problems because it creates questions of, is this really a fair test of the treatment? So in the context of experiments and treatments, we want people within a given group to be the same. So we want to have very low variability on whatever characteristic is being manipulated or treated. Another common example might be in the context of manufacturing and measurements. So we want to have low variance in our measurements. For example, if we're brewing beer, we want all batches of beer to look the exact same because we want to have consistency because our consumers come to expect a specific taste when they buy our brand of beer. And the fact is, it's simply not cost effective to develop the technology and spend the time and resources to make sure everything is done the exact same every single time. So the question becomes, how much variance in our ingredients or our processes is acceptable? Ideally, we want the lowest variance possible, but if some is going to exist, how much will affect the taste of our beer or whatever product it is that we're manufacturing? So the first index of variability we're going to talk about is range. And a range is simply defined as the distance between the largest and the smallest score for a given variable. So on the bottom left here, we have a data set with 5 different values, 9, 4, 1, 6, and 10. And if we wanted to calculate the range for this, we would take the maximum x, which would be the highest score in this data set, and subtract that from the minimum x, or subtract the minimum x from the maximum. In this example, the score would be 1. 10 minus 1 would equal 9. So our range is equal to 9 in this example. There are some problems with range, however. One of the main problems is that it only reflects the two most extreme values of a distribution. And I hope this example below with two hypothetical distributions illustrates that case. So in these two distributions, they both have an average of 50 and a range of 90. When we look at these scores more closely, however, we see that the distribution on the right, distribution 2, is a lot narrower than distribution 1. So they both have n's of 95 versus 5. But if we go in and look at the second lowest and second most extreme scores of distribution 2, we see a very different range. So if we took 52 minus 48, our new range would be 4. This is very different from a range of 90. So as a result, range is very susceptible and skewed in that sense by extreme values. Here's a different way of illustrating this same problem. In group 1, we have high variance because we have a very flat and a very wide distribution. There are about 4 scores for each group. For group 2, however, we have a very tall and skinny distribution, which would suggest most of the scores are concentrated around the middle. So although these distributions have the same mean and the same range, they're clearly very different. When is the range valuable to know? The range is especially useful when we know what the true range of a given data set is. This is especially relevant in the context of tests. So for example, there's the GRE quantitative section, and the scores on this test range from 130 to 170. If we were a graduate school admissions committee and our applicant pool range on the GRE quant was 159 to 165, what would that tell us? Well, essentially it would tell us that everyone is good at math. And if every single one of our applicants is good at math, that's a good thing, but we're going to need to use different criteria, maybe something like GPA, to select our students. The second index of dispersion is variance. Here are the two formulas for variance that both say the exact same thing. So on the left, we have x minus x bar. So these are deviation scores. How far does each score deviate from mean? Each of these scores are squared, so we have squared deviations, and then summed all together. This is an important point to remember. When you calculate the standard deviation or the variance, you want to make sure each deviation score is squared and then summed together, not in the opposite order. Then, of course, all of these are divided by n. This formula on the right actually says the exact same thing because part of this formula is called the sum of squares, or the sum of squared deviations, as I just illustrated. X minus x bar is a deviation. These deviations are squared and then summed together. Once you have this value, all you have to do is divide it by n, which is the number of observations in our data set, and that will give you the variance, which is indicated by this s squared figure. There are a few predictable steps we'll go through when calculating the variance. Every time you calculate the variance, I highly recommend creating a table that looks like this. So we'll list all of our x's, or all of the values in our data set, in the table on the very leftmost column. So here we are talking about this column, x. So we have 5 values, 60, 55, 46, 48, and 41. In order to calculate the variance, we'll first need to calculate the mean. You all know how to do that, which will essentially be summing all of these x's and then dividing it by 5. I calculated the mean for you. Here the answer is 50. So in the second column of your table, you'll fill out 50 for every single row. Next, you'll calculate deviation scores. And this involves subtracting each raw x from the mean. So 60 minus 50 is 10, 55 minus 50 is 5, etc. Once you've calculated all of your deviation scores, the next thing you'll do is calculate the squared deviations. That's indicated by x minus x bar squared. So 10 squared equals 100, 5 squared equals 55, etc. Now that all of your deviations have been squared, you're going to sum all of the squared deviations. So the sum of squares essentially involves just summing each of these values. So 10 plus 25 plus 16, etc. Once those have been summed, you have the sum of squares. The next step in our formula is to divide our sum of squares value by the number of scores in n. So once sum of squares has been summed, we have 226. And since there are 5 data points in our data set, 5 x's, we'll divide that. And in this case, our variance is equal to 45.2. Standard deviation is the third index of dispersion. And basically what the standard deviation captures is the average deviation from the mean in the data set. So how far on average are each of our scores from the mean? When we have large standard deviations, that would indicate we have a lot of variability in our data set and there is a wide dispersion of scores. If we have a small standard deviation, that would indicate scores do not deviate very far from the mean, and as a result, we have a narrow and skinny distribution. As you might have noticed, the formula for standard deviation is almost the exact same as the formula for variance. The formula is the exact same with the exception of adding the square root for the standard deviation. So these two indices are related very closely. Variance is denoted by s squared, and standard deviation is denoted by s. If you want to calculate the standard deviation and you have the variance, all you need to do is take the square root of the variance. So for example, if our variance was equal to 16, in order to get the standard deviation, we would just take the square root of that, which would equal 4. Of course, if we found that our standard deviation was 4 and we wanted to get the variance, we would simply square it, and that would give us 16. So as you can probably tell, the mean and the standard deviation are very important. In fact, they're the two most commonly reported statistics that you'll see when describing the different variables in a study. And the reason is because those two values tell us roughly what the middle of our distribution is for a given variable, and on average, how far the score deviates in that distribution. So in this example, if we had a mean of 10 and a standard deviation of 3, that might tell us our distribution is fairly wide and flat. If we saw a different distribution and knew that the mean was 10, but the standard deviation was only half a point, 0.5, we would know that the distribution is much taller and skinnier. Distributions with wide or narrow variance are not necessarily better than one another. It depends on the context. Sometimes variance can be good and other times it can be bad. For example, when we talked about manufacturing, if we want consistency, if we want our product to be made the exact same time and taste the exact same every single time it's made, we want low variance. Now we're going to go through a few example problems to get you used to using these different formulas. Again, these are probably going to roughly parallel the homework and quiz and perhaps exam questions that you'll see, so pay attention. So, using this frequency distribution, calculate the range, variance, and standard deviation. So, since we know what a frequency distribution is, we can create our raw data. On the x-axis, we have our different raw values. So we have 10s, 20s, 30s, 40s, and 50s. And we can see in our data set there is one value of 10, two values of 20, 3 values of 30, etc. So if we were going to arrange our raw data, it would look something like this, or it would look exactly like this. So we have 1 score of 10, 2 of 20, 3 of 30, 2 of 40, and 1 of 50. Because again, that's what our frequency distribution reflects. So first, we're going to calculate the range for our data set. And as we know, the formula for range is maximum x minus minimum x. So if we arranged our data in ascending order, we'll see that 50 is our highest value. That's our maximum. 10 is our lowest value. That's our minimum. And so in this case, our range would be 40. It's that simple. Next, to calculate the variance, we need to calculate our mean and then arrange a table. In this case, I've again calculated the mean for you already, since we've covered that equation in a different video. So the first thing we do, like I said, is we need to create a table. In the first column, we need to have all of our raw scores. In the second column, we need to have the mean arranged next to every score. To calculate deviation scores, we'll subtract the x from the mean, and that will give us a deviation. So 10 minus 30 is negative 20. 20 minus 30 is negative 10. 30 minus 30 is 0, so on and so forth. To calculate our squared deviations, we'll square each of those values. So negative 20 squared is 400, 10 squared is 100, 0 squared is 0, etc. Once we have all of our squared deviation scores, we can calculate the sum of squares. This is the formula again for a sum of squares. And as you can see, all you have to do is add each squared deviation together. Once we've summed all of our squared deviations, in this example, the answer is 1200, we can divide our sum of squares by n. N, again, is the number of observations in our data set. In this data set, we have 9 observations. So to calculate the variance, we would divide 1200 by 9. After reducing that formula, we see that the variance in this data set is equal to 133.3. Normally, rounding off to 1 decimal place is just fine with me. To calculate the standard deviation, we need to remember the relationship between standard deviation and variance. And of course, the standard deviation is equal to the square root of the variance. So since we know our variance is 133.3, all we have to do is take the square root of that value, and that will give us our standard deviation. In this example, the answer is 11.6. To quickly review, the main thing you need to remember from this module is how to calculate these 3 different indices of dispersion. Range is the simplest formula, but it also has the most limitations. It's especially useful to use when you know what the true range or full range of scores is, for example, on a test like the GRE. The variance and standard deviation are usually better measures of variance and dispersion, and the standard deviation is the most commonly reported and used.